Hello Minecrafters and welcome to Introduction to Redstone Computer Episode 3. From this episode onward, we will slowly bring our instruction set architecture to life. And to begin this journey, today we will design our Arithmetic and Logical Unit, or ALU for short. So just sit back, relax, and let's get started. ALU is one of the most important components present in the CPU. It is responsible for all of the arithmetic and bitwise operations in our computer, such as addition, subtraction, or NOR bitwise. For such important component, designing an ALU is actually not that hard. First, we need to see how each of our arithmetic and logic operations can be implemented, and then we just add them to our ALU. For example, in our instruction set, we have addition operation which adds two numbers in two registers together. To add two numbers together, we can use an adder. So we can either design our own adder following diagrams online, or just take a Redstone design made by other Redstoners, such as this one showcased in MyBatWing's Logical Redstone Reloaded series. In my opinion, it is fine to take other Redstoners' builds as long as you credit them, share their work to other people, and give them the recognition that they deserve. You don't have to design everything by yourself if you don't have to. Other operations are pretty much the same. Here I have a subtractor for our sub operation. Here are 8 NOR gates for our NOR operation, and here are right shift and left shift for our bit shift operations. The next thing that we need to do is we need to connect our two number inputs to all of these components. This can be done pretty easily with a single set of wires per number connecting to the inputs of all of the components. Now, if we just input some numbers like 5 for number 1 and 3 for number 2, we can see that our adder is outputting 8 because 5 plus 3 is 8. Our subtractor is outputting 2 because 5 minus 3 is 2. Our NOR part is 0 because 5 NOR 3 is 0. And the number 5 is being shifted right and left here. However, we don't really have a way to select these outputs. So to select which output that we want, we first need to put gates in front of the outputs, and then depending on our designer output, open the corresponding gate. To open these gates a bit easier, we can use a decoder which decodes a binary code into a corresponding output. Since we have 5 components, we need 3 bits to represent numbers from 0 to 4, which are pi numbers. And congratulations, you have built yourself an ALU. I decided to go with this because it is super simple and easy to understand compared to the ALU which uses carry cancel adder at its core. You can use that version if you want your computer to be compact, but compactness is not the goal of this series, and this ALU is more than enough. We have officially made our first component for our CPU. In the next episode, we will get to the register file and how to connect it to our ALU. I hope that you enjoyed today's episode, and I hope that you have learned something as well. Thank you very much for watching, and I will see you all in the next episode. Have a nice day, everyone.